Okay, so the region is the interval from x equals 0 to 1 because x is integrated from 0 to 1, right? And I've got these backwards. Okay, the problem stated it was this interval and then this, right? So it's y that goes from 0 to 1. Then x has limits y and square root of y, so you have y less than or equal to x less than or equal to square root of y. Okay? So here's y, here's x. Now we just did this in paper, so I'm going to do it rather quickly. Y goes from 0 to 1. And for a given y, x goes from y to the square root of y. Okay? So here, x equals y at this point, and x equals the square root of y at this point. Okay? Whatever y is. Now, if y is less than 1, if y is between 0 and 1, its square root is, the square root of y is bigger than y. If y is bigger than 1, then this would be bigger than this, but that's not going to happen because y is confined to be between 0 and 1. So we're assured that these inequalities make sense. Okay, well, if x equals the square root of y, then at this point, y has to equal x squared. And at this point, of course, if x equals y, then y equals x. That's kind of a no-brainer. You don't have to do any algebra or anything, right? Well, that means that if we plot y equals x, and plot y equals x squared, then our region is going to be confined between these two graphs, okay? Now, the way I drew the graph isn't particularly accurate because I haven't actually figured out what this intersection point is, right? When I said y equals x and put it here, and then y equals x squared, or x equals square root of y and put it here, did I really put that point in the right position? I didn't calculate it. So if I use this point as a guide for graphing my y equals x squared function, that intersection point might not be where it really goes, right? Okay? So the region is something like this. So it's something like this. It's going to look something like this, but the scale might not be right. Okay? Well, where do those two graphs intersect? Well, where x equals x squared. Now I'm going to do something different than what I did when we just discussed it. Just to give you actually maybe a simpler option, but you have to have both of these ideas you know, the one I discussed and this one. Okay, so yeah, that can be arranged to x squared minus x equals 0. So that x times x minus 1 equals 0. Well, the only way this times this can be 0 is if either this is 0 or this is 0. It's a zero property multiplication. Okay? So the solutions are x equals 0 and x equals 1. Okay? Well, that means that this point of intersection should be the point 1, 1, right? So we have an intersection at 1, 1. But of course, when I labeled this graph, I put 1 here. Okay? And I probably shouldn't have done that. Okay? So I have two choices. I can redraw the graph with this point a little further over here so that, well, I can redraw the graph so that the parabola intersects when y equals 1, right? Or I could cheat and just say that, okay, that must have been where y equals 1. Okay? And then this x equals y labeling doesn't really work, so I'll just say x equals y and put the arrow here. Okay? I could have redrawn the graph. I could have done the algebra and figured out that this is going to be a parabola, if there's a straight line, they both go through the origin. Just draw it and then put the labeling in, right? But anyhow, that's what the region looks like. Okay, well, now we want to see what this integral might represent. So that's not part of the problem that was assigned. Probably you worked and you did the integral correctly. So let's find out, I think you did the integral correctly, look good. Let's find out if it's plausible and just maybe what it means in terms of a graph in 3 dimensions.